Good day, Professor Chokorda and friends. My name is Kezza, and today I'm gonna present you all a presentation about material process, and the topic is advanced machining. Laser beam machining. In laser beam machining, or for short LBM, the source of energy is a laser, which focuses optical energy on the surface of the workpiece. The highly focused high density energy source melts and evaporates portions of the workpiece in a controlled manner. Laser beam machining is used widely for drilling, refining, and cutting metals, non-metallic materials, ceramics, and composite materials. Laser beams are also used for welding, heat treating of metals and ceramics to modify their surface properties, and marking of parts such as letters, numbers, codes, etc. Electron beam machining. The energy source in electron beam machining, or for short EBM, is high velocity electrons, which strike the workpiece surface and generate heat. Applications of this process are similar to those of laser beam machining, except that EBM requires a vacuum. Consequently, it is used much less than laser beam machining. Electron beam machining can be used for very accurate cutting of a variety of metals. Here is for further understanding. Here is a video about electron beam machining that was taken from GE Additive uh, from YouTube.
Additive manufacturing offers greater freedom in design and allows for the creation of optimized parts that are not constrained by the limits of traditional manufacturing. RCAM EBM has the unique ability to tightly stack parts within the build in order to increase productivity. An optimized build file is sliced and loaded into the RCAM EBM system. Following this, metal powder is loaded into the machine. The build chamber is then closed and a vacuum is created to ensure a clean, controlled environment that allows for the processing of reactive material. Next, RCAM EBM's powder layering system evenly distributes a thin layer of powder on the build area. A powerful 6 kilowatt electron beam heats the powder bed to the optimal ambient temperature and then proceeds to melt the powder. First, contour melting and then hatch melting. The electron beam unit generating the beam contains no moving parts, allowing for extremely fast and accurate beam control. The build environment is kept hot, reaching temperatures exceeding 1000 degrees Celsius, resulting in no residual stresses and allowing for the processing of crack-prone materials. As each layer is completed, the build is lowered and a fresh layer of build powder is raked over it. This process repeats, throwing the build one layer at a time. When the build is complete, the tank is extracted and the RCAM EBM machine is prepared for the next build.
Waterjet machining. Waterjet machining that have a force resulted from water or gas turbines is utilized in cutting and deburring operations. Because it is an efficient and clean operation compared with other cutting process, it is also used in the food processing industry for cutting and slicing food products. The advantages of this process are as follows. Cuts can be started at any location without the need of pre-drilled holes. No heat is produced, no deflection of the rest of the workpiece takes place. Thus, the process is suitable for flexible materials. Little wetting of the workpiece takes place. The bar produced is minimal. It is environmentally safe manufacturing process. Abrasive jet machining. In abrasive jet machining, or for short AJM, a high velocity jet of dry air, nitrogen, or carbon dioxide containing abrasive particles is aimed at the workpiece surface under controlled conditions. The impact of the particle develops a sufficiently concentrated force to perform operations such as cutting small holes, slots, or integrate patterns in very hard or brittle metallic and non-metallic materials, deburring or removing small flash from parts, trimming and beveling, removing oxides and other surface films, and generally cleaning components with irregular surfaces. Hybrid machining systems. A more recent development in manufacturing is the concept of hybrid machining systems. Two or more machining processes are combined into one system to take advantage of the capabilities of each process, increasing production speed and thus improving the efficiency of the operation. Examples of such systems include combinations and integration of the following processes. A. Abrasive machining and electrochemical machining, abrasive machining and electrical discharge machining, abrasive machining and electrochemical finishing, water jet cutting and wire EDM, high-speed milling, laser ablation, and blasting as an example of three integrated processes. F. Machining and blasting. And the last one is electrochemical and electrical discharge machining, or for short ECDM, also called electrochemical spark machining, or for short ECSM, etc. That's it for my presentation. Thank you all for your attention.